Hello, welcome to everyone. In this video, this is our lecture number 19. Already 18 lectures are covered. From lecture number 1 to 7, we discuss the differential equation solution by Frobenius method. Then lecture 8 to 14, we discuss about the partial differential equation by separation of variable. Then 15 and 16, we discuss about the Fourier series. Then 17, we discuss about the some special integral function, beta function, gamma function, error function. And the last lecture we discuss about the Fourier transformation in detail. Total Fourier transformation we discuss in the last lecture. And in this lecture we give you some problem uh, that will be discussed in this session. The problem asked in this session and some additional question we want to discuss in this session, right? So I think you clear about the flow of this lecture series. If you wants to watch the previous lecture, you can go through the description box, link are given there. You can see this portion of Fourier series will be was discussed in 15 and 16 lecture. Frobenius methods solution from lecture 1 to 7 we discussed, and some special integral discussed in 17, lecture number 17. Fourier transformation, integral transformation discussed in 18, and in this lecture we want to discuss rest of the part, and this is the remaining part. In the upcoming session I want to cover up this portion, and this was discussed from lecture number 8 to 14. So clear, I think clear about the flow of this lecture series, right? So look at this question. What will be asked in the last session? That's the first question is was this is the function from mod x less than 1 means the x value is -1 to +1. This f of x is 1, otherwise this is 0. Find the Fourier transformation. Very simple. Take this Fourier transformation formula, 1 by root 2 pi minus infinity to plus infinity, but in this is -1 to +1, this is exist, that's why it take to 1. And just taking this integration exponential, you will be get easily find out this solution. This will be root under 2 by pi sine k by k. Clear? Next question. Define Fourier transformation of a function. Obtain this. So this question will be the solution of this question, or the answer of this question you can easily write down if you watch the previous lecture, right? Then obtain the Fourier transformation of a function of like that. So using this formula, so the Fourier transformation of this equation is the basic formula of the Fourier transformation. Using this formula and use this definition, you can see this alpha is alpha, but beta is nothing but I omega. So put the value beta as a I omega, you will be get this answer. Simple. Next question. Calculate the Fourier transformation when f of x is the Dirac delta function delta x. So you need to find out the you need to find out the Fourier transformation of delta x. You can see here this is the Dirac delta function in integral form. If you take the Fourier transformation, this will be 1 because the product of these two must be 1. So since this is 1 by 2 pi, so this is 1 minus infinity plus infinity. This one. This is the property of delta function. Using this property, we can see here this is the delta x minus 0 here, and this is f of x. So put this x equal to 0 in this f of x, right? So this is the Fourier transformation of delta x is 1. Okay, this is an important formula. We will be use this in the upcoming question also. Next, find the Fourier transformation of this function and hence calculate this integral. So the first question already discussed in question number 1. So from this question number 1 we got these things. The Fourier transformation of this f of x is like that. So this f of x nothing but the Fourier transformation of this one. So Fourier transformation of this one. So f of x will be Fourier transformation of this one, putting this value. And if you put this f of x equal to 0 in both side, you will be get f of 0, and this x equal to 0 is 1. So you will be get this integration. So this integral value will be pi, and this is the even function because this is odd, this is odd, so this odd cancel out, total will be even. So this 0 to infinity, since this is even function, so there will be 2. and this 2 in the right hand side pi by 2. Clear? Very simple. This is an important question. Next, evaluate this integral where the prime denote the differential. So this can be written as the partial. This is the parts. Sorry, this is the product of the integration by parts. You know the by parts. So the integration of this function and taking the derivative of this function. So this integration of this derivative. This is the derivative. So integration will be delta x, and this is the derivative. So integration will be that one. So this is the, so this will be the delta x, and you know this is nothing but, if you put this value e to the power 1, but only x equal to 0 this exists, that's why this is e to the power 0, and here this also using this formula will we get e to the power 0, so finally we get 0. Next one, so that the Fourier transformation of f of x equals to e to the power minus mod x equal to root under 2 by pi 1 by 1 plus x square. This is an important formula which will be used in the upcoming question also. You can see this is the Fourier transformation of this one. So using this to the power minus kx, separate out in two part, greater than 0 and less than 0. After that, just taking just integration and calculating, you can easily find out this solution. Simple. Next question, prove that delta x equal to 1 by mod delta x, and this was actually discussed in the last session. I think you understand in the last session this proof of this question. Next question, find the Fourier transformation of this. So it's a constant. So you know this is the definition of that one and that one. So Fourier transformation will be like that. Actually this must be taken as 1 by root 2. This must be taken is the 1 by root 2. So you can write down in this form, taking this integration. Sorry, taking this integration, and this is the nothing but cos kx. Next, consider this from function and calculate the Fourier transformation and state the limiting value when a tends to 0. So put this value and minus a2 plus a, this is 1 by 2a. So integration you will be get these things. This is sin k by a. When take a tends to 0, so you know this is 0 by 0 from L hospital rule. This gives you 1. So this is 1 by root 2 pi. Next question, consider this a function where x tends to plus minus infinity. Fourier transformation is like that. Fourier transform. So this is the Fourier transformation and this is the derivative. So this actually discussed in the last lecture. So just put this slide here. Yeah, this proof actually discussed in the last session. Clear? Next, this is asked in JEST 2020, that is f of t real and even function. F of t is a real and even function, which is the corresponding statement is true about this function where star is complex. So the Fourier transformation is nothing but this of that, and if you expand this in cosine and sine function, you can see here, since this is a even function and you know cos is even function, so product of two even function is even function, but this is even function, this is odd function, product of even and odd is odd, and since this is odd function, minus infinity, this becomes 0. So only this become present and there will be 2 arises here, and you can see if there is no complex number, so if you take star, this will be give the same thing, so the solution will be B. Clear? Next question, what is the value of this integral? What is the value of this integral? This can be expand in this form, this can be expand in this form, and you know this cosine, taking this cosine, and this is the property of the delta function, that x when x equal to pi, this is exist, otherwise 0. So put x equals to pi here and x equal to minus pi here, right? So this is the answer. Next question, Fourier transformation of this proportional to a constant of this. So this can be expand in this form, you can see, and just separate out these two things, and using this formula, this is the standard formula, and this can be derived in the Fourier transformation also. But at this moment you remember this formula, you can easily put this value, you can get the answer, right? Next one, consider the array of the one dimension SMB average periodic density as shown in this figure. This is a periodic function like that, where this will be denoted Fourier transform of density correction relation. So you need to find out this ratio. Okay, so you can see here this function will be like that. This is the Fourier transformation. This is the function 1 by delta, and so this is the function exponential and delta x. Now I take this summation because there is a discrete form, that's why I take the summation, and this is for Fourier transformation. Fourier transformation within this periodic nature. Okay, in this nature we will take this transformation, and the summation takes the all the count, right? So this integration will be like that. When putting this value, you will be get this sine function and take this summation. After that, this is the infinite GP series, right? This is infinite GP series, and the in sum of the infinite GP series is a by 1 minus r. A by, this is first term, by 1 minus r is the common ratio. Okay, so this when delta is 0, this is 0 by 0, which is 1. 0 by 0, L hospital rule, this is 1. So finally get this one. So if you take this ratio, you will get this answer. Clear? Next one, consider a sinusoidal waveform of amplitude 1 volt and frequency f naught. Starting from an arbitrary initial time, the waveform sample interval of 1 by 2 f0. If the corresponding Fourier spectrum f prime and a prime, then this into value. So the Fourier transform, this one equals to like that, and this is the function, this is the sine function, you can see here, this is the sine function, sinusoidal function. So this exponential can be written in two form, and separate out these two, you will be get this exponential. You can see this will be, the frequency will be 2 times and the amplitude will be half, right? So that's why the amplitude will be half of a. Actually this will be a, not half. There will be a, okay, this is 1, that's why this is because this is 1, so this is half, no problem, this is half. Next one, Fourier transformation of derivative delta, derivative of the Dirac delta function is this. Actually we discussed in this question, so there will be ik, so the answer is D. Next question, in the graph periodic function, this is a cosine function, this is a cosine function, you need to find out the Fourier transformation of this cosine function. So this is a cosine function, and this formula will be written in this form. Property number 4 can be used here, and from here this is directly can be written in this formula, that is the this will be through delta function. Clear? Next one, the Fourier transform of this, where this f of x given like that, where delta x is the delta function, prime denote the derivative. So you can just expand this is f of x, this is f of x, and this separate out in three part, and you can see from the property of this delta function, this will be exist when x equals to 0. Put this x equal to 0, and there is a ik, first derivative ik, and there is x equal to 0, second derivative ik square. So finally you get this answer. Next one, what is the Fourier transform of this, where this is the form of f of x? So f of x can be written in this from, and this you know the derivative, sorry, Fourier transform of Dirac delta function is 1. So the Fourier derivative of delta to the power n x will be nothing but minus ik all to the power n delta x. So this will be the value. So the Fourier transform of this one, nothing but the summation of that one, will be get 1 by 1 plus ik. Clear? You can see this is nothing but 1 minus x whole to the power n. This formula is 1 minus x whole to the power n. Next one, the Fourier transform of this one, where this function is like that. So this is the function, and this is the formula. We write down this formula here. You need to remember this formula so that you can easily solve various type of question, right? So just use this formula here, here also use this formula here also. You can finally finally use this formula. Okay, here written here also. So this three important formula you can remember, it will helpful. Next question, the Fourier transform of this, where this function is like that mod us to the power minus mod x, which already discussed in the same process we discussed in the previous question. Okay, and the next question, this is question asked in GATE 2015. That is the heaviest function is like that. The Fourier transform is given like that, whose Fourier function of like that. Then the Fourier transform of this one. So Fourier transform of this one can be written in this formula. That is the shifting property will be like that, using this omega by 2, and this is minus omega by 2, and this is the Fourier transform of this one. So just rearranging them, you will be get the answer. And the next one, who is asked in the West Bengal State University, West Bengal State eligibility test set examination. Uh, then this is also a Fourier transformation angular frequency. So question is, two of the following frequency at which the Fourier transform becomes zero. So you need to find out the Fourier transform of this equation. This is the similar process which are discussed in previously. Will we get the sine omega by omega? Okay. After that, when this will become zero, when omega is pi, 2 pi, 3 pi, and so on, this becomes zero. So the B and the correct answer. Clear? So you understand what is the importance of the Fourier transformation, or level of all type of competitive examination also ask this type of questions. So you must practice this Fourier transformation as much as possible, such that you can memorize it, and it will helpful for different competitive examination also. So that's it. This is all about me. This is my contact details. You can connect with me with the Telegram channel, and this is my YouTube channel details. Go to this channel, will be get the different physics related video, some mathematics for your general or pass course. Like this session, if you learn something from this session, share this video to your friends so that he or she also get benefit from this video. Subscribe this channel if you new in this channel, and those already subscribed, thanks for subscription. Press the bell icon to get the notification of upcoming video. So take care. We'll meet in the next video as soon as possible. Thank you.